Hi there guys, my name is Mike and I am here to show you in this really cool video that I kind of slapped together here. Hopefully I don't ramble on for too long. That wiring with DC for a model railroad can be actually quite easy, and it works. It actually works really well. I think the first thing to kind of go through is the tools that are used, the materials that are used, my switches, and last but not least, the cab control. So this cab control was given to me from my grandfather, probably about 5 years ago, and it's a dual cab control. So you got cab 1 and cab 2. For being quite old, it still puts out a decent amount of power. Has momentum controls, both direction and the actual brakes. You can ease in to stopping the locomotives. Tells you what your track voltage is by just a light getting brighter, and tells you when something's been overloaded by this red lights here. Tells you when your momentum's on. It's a really cool system. From there, what I've been using, just as an example for right now, is just your standard N scale gauge. For right now, I have an F Series Canadian Pacific locomotive as our test, and the other materials that are going to be used or have been used, just your standard suitcase connectors, waterproof switches, which I'll get into, terminal connectors, which are also, I should say, strip connectors, and just your standard spade terminals, which are used all over the layout, or this test layout. Now the one thing why I was using DC or decided to use DC is the fact that I don't have a lot of money to invest into a decent DCC system, and I still think that learning the basics of DC is important before you apply those fundamentals to DCC. I know that's a pretty strong opinion, but I think this was kind of fun doing some tests as well. It was kind of fun getting my hands dirty doing it. But anyways, pretty much the basics from what I've been doing a lot of reading on and a lot of researching on is pretty much this. When it comes down to it, DC is all in the fundamentals of controlling electricity through blocks. And in order to do that, you need to have insulated rail joiners, which are right here. So basically what I've done is I've separated each block into block A and to block B. And to separate them, there is this insulated rail joiner. Now, to supply power to one rail, you need a consistent current through one rail, and that's your common rail, and that won't change on the whole layout. That is going to remain unchanged. So what you need, and a lot of the time they've shown in books and all the tutorials that are out there, is you take your negative terminals and you have to piggyback them together. And so that's what I've done. I've taken negative, run one main wire straight through, and did a really quick soldering job. I don't recommend doing this. This is just for a test. What I've done is just tin the wire and used the solder from the tinning and soldered it to the physical rail itself. Now the one thing that came in really handy are these suitcase connectors, and pretty much I slid the main wire through the suitcase connector, took cab 2's control, and just piggybacked it off there. So there's no soldering involved whatsoever. It's nice and clean. All you need is a pair of pliers to conjoin the two in the center, which is this little metallic tab. It presses down, and voila, you have a two-wire connection instantly. So there's your common rail, which I've listed as CR. That's going to come through, and bingo, there's your common rail. And through this entire rail, right here, it's all solid, or I should say it's all one current going through it. And there's a metal joiner right here, not an insulated one, because you need that to be your common rail. Now, the other thing that you're going to need to do, which is very easy, is figure out how many blocks you want to break your model railroad into and how many cabs you're going to be running into it. You can have single cab, with 4 blocks. You could have single cab with 8 blocks. It doesn't really matter. It just depends on how difficult you want to get into it. For right now, I'm going to show you 2 cab control with two blocks, A and B. Now, you're going to need however many switches for however many blocks. For example, I have block A and B, so I have two switches to correspond, so I can transfer power from cab 1 to block A or power from cab 1 to block B, and that's where you have to use your switches effectively. To start with the wiring basics, cab 1, which is right here, and it is on the far left, I took the positive from there. You route your main wire to the positive, which is going to be labeled as cab 1, straight through here. And I wired it straight to one of these terminal strips. Now the reason why I'm using terminal strips is because I don't want to solder all these joints together and have to worry about shorts or any nasty connections. This is very easy, it's very effective. The connections hold tight, they're not going to come and pull out. Now you might be wondering why you need this many. Well, you need that many for the main reason of each block controller switch needs a line coming from your cab to control that block. So pretty much what I've done is I have two lines from cab 1 going to here, and each one will be routed off to a block selector switch. The exact same thing is coming from cab 2 all the way here to block B. Now the basics of this, going back to the center here, is I've taken another suitcase connector, doubled it up again, so I have right here cab 1. So there's cab 1 wiring right there, and that goes to one side of my switch. So that's going to be allowing me, when I flick this switch over, to going to cab 1, allowing that block A, which is marked here, to get power from cab 1. Now the same is done to block selector switch B. I have the second line coming through here and connecting to the number 1 here. And that is so that if I flick it on block B, I'm going to get power from cab 1. Now it's just duplicated all the way through. I'll go through this quickly to keep this video short and tidy. Master positive is coming out on cab 2, comes into terminal switch, comes up, and I have my two lines, one for block A, one for block B. Now the reason why I chose these toggle switches is, in all honesty, I don't like the look of the Atlas selector switches or the power selective units. These ones right here are really nice. I work for a motorcycle dealership, and we sell a lot of marine and ATV accessories. And with these switches, what you're going to need is it to be on either side and then off in the middle. And they're really, really nice. The switches do hold their strength. They're completely waterproofed on the encasing, so they're going to resist oxidization. And I like the look of them. It's a cleaner look when I create my own custom panel. You can use Atlas selector switches. There's nothing wrong with them. They work very well. It's just I prefer the look of a customized switch panel board, and these fit the bill very, very nicely. Now, once you have all your wiring routed properly, so you have your common rail, and then you have your cab control wiring to your switches, you're going to need another line, which is right in the middle here. Now, the O represents for off. Basically what this is your cab selector line, if you could call that. So cab A, you're going to have your single one running down here and going to block A, I should say. So block A switch down to block A. Block B switch running down to block B. So this is where the power from cab 1 or 2 is switched on or off on the actual blocks. Now, from here, there's not really much else to show you besides just kind of showing you the fundamentals of DC wiring in motion. I'll turn on my power pack here. So I got a light showing me it's good to go. Now, for example, if we want to move locomotive in block A with cab 1, you have to just flick your switch right here over to 1. Done. That's it. Now cab 2, it doesn't have any power whatsoever because I don't have any switches hooked to number 2. Block B is unpowered as well because I don't have any switches selecting power to go to it. So let's switch that over to 1, like so. Boom. So both blocks are now receiving power from cab 1. So if I go over to cab 1 and turn up the dial for power, our locomotive should move. All the way over to block B, I'll change direction. Done. Now you're wondering, well, what happens if, let's say we turn off power to block B? So I'll turn power off from block B, and I'll run the locomotive clear through to block B. Because there's no voltage or no power getting to it, you've effectively turned off block B. It's not going to move. It's not getting anything. So pretty much this is the basics right here of DC. You can have one cab running one locomotive in a certain block. Make sure your toggles are flipped to the right cab, and at the same time you can have another locomotive in another individualized block isolated from the other one, and it's isolated by that insulated rail joiner. Now if we go back to here, now let's say we wanted to play around in block A or B using the switches, but with cab 2, there's cab 2 underneath my right thumb. I'm going to switch that to cab 2. I'll switch block A as well to cab 2. Now, if you notice, I'm playing around with cab 1. It's showing my track voltage going up, but nothing's happening. Because there's no power from cab 1 getting to it. But if we use cab 2, turn up the dial, voila. So pretty much all in all, guys, it's very, very easy to wire. The very basics of DC are just finding the right set of switches to control the power in your blocks properly. Atlas is pretty bulletproof. You can have each individual switch connected back, piggyback to piggyback, and then you just have to connect your common rail and your block selector lines all effectively. I like the custom wiring aspect because it's a little bit more work, and like I said, I like doing a lot more, a little bit more freedom there to do whatever wiring you really choose to. I know you might be wondering, why did you do this test? It's because it's my first time playing with DC wiring, and it's a lot easier to spend $10 to $15 here than doing, let's say, $100 mistake down the road. And this was the first time, and it worked bang on. You don't effectively have to use any of these switches or anything I've shown here. This is just one route that I've chosen that I think is going to work very well on the layout. DCC, though, I can see will very, very much effectively eliminate a whole schmuck load of wiring. There's going to be quite a bit of wiring involved, but that's why I'm getting brass hooks to hang actually underneath the layout bench itself, to hang all the wiring that's going to be involved, as well as drilling a small 2x4 in it and putting these terminal strips all down them and having just the same kind of thing, tape marking off which cab does what. In the near future, I will post a video on how to properly DC wire an insulated turnout, which I'm going to experiment with here in the next couple of days. If you guys have any questions, please be free to ask me. This is Mike signing off. Hope you enjoyed the video.